All right, thank you for the intro. Hopefully you can hear me well. Yeah, sorry for the technical difficulties here. So AR, VR, XR, whatever you want to name it, Metaverse, it's all really interesting and challenging, mesmerizing concepts. And the goal here is not really to try to define them or go deep into this, but really think about practical aspect of this. One of the common theme about all of these concepts, though, is the idea of immersions. It's kind of the promise of an embodied internet where you are in the experience and you feel things just like if you were present there. So this kind of begs our very practical questions before we can experience all of these is how are you going to be in the metaverse, and who or what even are you going to be? So these are important questions that we're going to all have to answer before we can experience these through whatever media we choose to. So it's all about you. And this is kind of the purpose of this talk is try to answer some of these questions. We don't have definitive answers. These are really research efforts that we have. So it's ideas and explorations, maybe more questions than answers, but I think it's a very interesting and exciting topics. So what's going to be the answer to that? And most likely, you know, looking at this snapshot from one of the Facebook Connect announcement of the metaverse, there's not going to be a single answer. You might want to be something very different depending on what you do. You might want to be like a big cartoony robot. You might want to be exactly yourself, or different characters based on your personal preference and the context of where you're at. So, as I say, in some cases, you may want to be your true selves because you want to talk to people that are close to you and they don't want to see anything else but you as you are in the moment. That's important. In some cases, you might want to be bold and move toward the aspirational version of yourself and like, hey, how about just start customizing and some cosmetic changes? Why not? And moving further, you might want to be a stylized version of yourself. So because you're doing things that are more creative or exploratory, it's still you. People might recognize you, but it's not really. There's a lot of animations going on here. And moving further, you can want to be something completely different. Here, it's just a random characters. It doesn't look like you anymore, but maybe you can share some of your attributes, the way you move, the way you emote, and all of that. Or you might want to be something completely different, not even a human. So at this point, the goal is not to pick any of these, but to say, okay, what can we look into solution? What kind of solutions can we look into that will enable this broad spectrum of potential characters? Now, beyond how you look, there's the question of what you're going to be able to do over there. You're not just people in a vacuum. You want to be able to be part of the world and interact and have this thing called a sense of agency, which means that you feel like your actions have consequences on the world. So in this example that we have, you might want to be able to interact with either virtual or practical objects, share a chessboard and move things around. So there's some form of interaction here. You can go even beyond that if you want to do some things that are even more physical, where the whole body here is important. So there's a different level of immersions, but the sense of interactions and agency is very critical to preserve that level of experience. Another interesting aspect to consider is how much data are you willing or capable to provide to the system. In some cases, for practical reasons, because in this example, you're wearing AR glasses, the amount of data that's available to capture your body or emotion is very limited. It's whatever the glasses you're wearing can see. So maybe there's 6 degrees of freedom where you're looking at, maybe a slight vision of your eyes, but that's about it. In some cases, you might be able to provide the data, but you don't want to for privacy reasons. You don't want to disclose how you look or what you're doing. And the other end of the spectrum, you might be willing to just put on a motion capture suit with all the sensors, the haptic gloves, the visor, the cables. Hopefully we don't need that, but the idea is like people have the choice to provide as much data or as little as they want to, depending on the context. So one of the promise though of AR, VR, and XR in general is defy reality. So a lot of initial tests and prototypes that we've been looking at so far are about recreating reality, but just defying distance, which is a fundamental aspect of it and very promising, a very hard things to solve. But something to keep in mind is that one of the holy grail of these metaverse approaches are to defy reality. We don't have to only stick to reality, as I was just explaining. You can be creative in how you look, how you move, and how you interact with things, and defy the laws of physics and exploit user creativity. That's an important aspect of it. So one way we'll look into that, putting all of these kind of on a spectrum. So all these appearances I talked to, they kind of form a continuous continuum here. From the left, it's the reality. Nothing has to be synthesized. And you can imagine that we have like a creative knob that we can turn. And the more we go to the right, the more creative input is required, and the more people can start expressing themselves. What that means also is that the systems will have to kind of provide a lot more data and synthesize information here, because it's no longer you. So there's data that can be provided as priors, as models, but there's also motion and things that could be synthesized. And in the same way, in terms of inputs, you can start fully user-driven. You provide everything, to providing sparse inputs to providing no input at all. And this also forms a continuum spectrum. So it's kind of formed this realistic on the left, where it's me and I provide all the inputs, and I can do these immersive calls, all the way to the right to fantastical characters that are almost autonomous. And really, we want to try to explore solutions that can enable this wide palette of characters and behaviors, which is very challenging. One of our goals is really to enable you to be what we call your true virtual selves, whatever that may be. And every world is kind of important. Because we want you to feel like you're present there, and it's you get all your senses that were stimulated. It's your true self, so which means that you feel like it's authentic to whatever your aspiration is. It feels true, it feels genuine, so you can really interact and have emotional connection to other people. The virtual aspect of it is because we want it to be portable and like a transmedia experience, whether it's AR, VR, or any kind of platforms. And self is because the idea is we want to create an entity that feels like a person with its own emotions and small persona that's close to you if you want it to be, or that's something else if you decide it to be. So there's multiple ways to attack that problems, and who knows how things will unroll here. We can definitely have people start building their own characters from scratch, but for the rest of this talk, we're going to go through this in kind of the orders that we presented, just as an exercise. Starting with, okay, focus on yourself, and then start stylizing it, and then start designing characters and see what are the options that we have here. So the first part is like, oh, let's start with your clone. Okay, what can we do here? So what we're looking at here is like, can we have a system that understand whatever data is available? Let's say it could be a lot of data, it could be very little data. So in order to deal with that data scarcity and noise usually and issues, the idea is we're looking at priors that are based on human beings, because we want these to be driven by humans. So can we have like a character framework that will understand this data and complement it, as I say, because it's going to be only partial observations, and rig all these things so that we can have a solid basis to reconstruct you, and then retarget that information onto the characters that you want. So the way we're looking into this is, first, we have to learn about how do people look and how do things move and behave and deforms and interact. So we're capturing a lot of data, a lot of examples of things, just to learn what are the fundamental physical behaviors behind this, in terms of light, in terms of forces and all this. So one of the first area we'll look into, for example, is how does people look, and understanding the biophysical structure of the skin. The idea here is we're looking to do a biophysically accurate rendering of humans. And one way to do this that's just generalizable is like understanding, okay, what makes the skin looks like it. It's a very complex thing. The light scatters through many layers of the skins, and what we looked through our research that's been published is that there's a kind of a basis of chromophores that will directly impact the way that you look. And if you understand these chromophores and these different parameters of the skin, then you have a model that can pretty much explain anybody, regardless of your skin tones, of your current blood flow, and all these kind of things, of your age, all these. So the idea is to find a basis that can be generalizable so that it's applicable to anybody, and then we can render these under any conditions. So beyond how you look, we're also interested into how this fabric behaves, because there's a lot of to reproduce clothing and simulate clothing accurately, we need to understand this. So we do the same thing for fabric, and looking to appearance models that are very accurate at the fiber level. understanding the reflectance models, how light bounces off of this, of skin or hair or fabrics, of the structure of fibers. All these things are important things that we kind of study. So as a kind of interesting test that we've done here, it's an example of differential simulations. When you understand how cloth deforms, here the idea is like if you have an observation of someone with their clothing, so you have the kind of the outer layer where you can see, can you infer what's the body geometry underneath the clothing is? So on the left here, what you could see is an initial body that starts as a neutral body, and it kind of deform, and it reaches the results in the middle. So it's a combinations of physics and inverse simulations to try to infer information that's not directly observable. So that's an interesting aspect of it. Now, beyond this, we're also interested into capturing surfaces and deforming surfaces and dynamic surfaces. So here the idea is like you have someone in motions, and we want to reconstruct in high fidelity all the details of that. And once again, this is what's observable. And one of the goal here is to try to infer a lot of the structure of the human being here, understanding where the clothings are, where the skin is, and all of these, so that we can start to deconstruct that person and retarget that. So in order to do this, there's a lot of semantics information that's required. So we do a lot of work also on semantics. So here are a couple of examples. One is about real-time key points detection. There's a lot of work on that, and it's pretty amazing that what you can do in real time. You have hundreds of points that are detected. On the right is kind of a real-time segmentation. You can see the model is kind of learning what is skin, what is hair, what is clothes, what is shirt versus pants. So some interesting results, and that's powered through machine learning. An interesting piece of work that my colleague here, Nikos, will presenting at this CVPR is like it's a dense correspondence. So that's kind of an amazing result. Here's the idea is that we want to have both spatial and temporal consistency. So the idea is that you have a human moving in time from different views, and you can have a pixel accurate, and regardless of where the pixel lands, it could be hair, it could be skin, clothes, and you have the information where things are moving in time and space, which is great. So if you combine that with the segmentation before, you can know exactly where the piece of fabric is going and how it's deforming over time. So putting this together, we're also looking into capturing your motions from RGBD sensors here, and the idea is like having a solution that's flexible, that's kind of robust to occlusions, like here, for example, you can see, and what can be done as a markerless, very low friction solution, and inferring that. So there's many things happening here. There's first detecting the person, segmenting them from the backgrounds, understanding those skeletal motions, and all these things put together to have something that's quite easy to use and reliable. Now, in order to get more details, we're also looking into the dynamic of the surfaces. So here, even though there's some issues, the idea is like, okay, we have the motions of the hands, we have the deformation of the structure of the cloth here. How much details can you capture in real time? How much can you infer? And how much of these are you interested in preserving? And how much of these will you be able to retarget to something else? And one fundamental layer that's kind of a core of all of that is having a very accurate skeletal motions. And once again, the idea here is like, if you have that information, you can use it to reconstruct yourself, but you can use it to retarget that to whatever desired characters that you have. So the motion is kind of the critical aspect that's common to any forms of characters that you want to enable. So having good and solid motion reconstruction is very, very important. So one of our goals is really to try to push this model so that they're generalizable by nature, and that they can have a level of quality that's really compelling. So here's an examples of a test that we did, where one is the real capture and one is a render. And so we're really trying to push the level of quality to say, okay, if we have that level of quality, can we have immersive experiences that are really compelling? So here, there's no stylization. The goal was just to change the lighting and see how the model holds. And we're also doing some tests of scalability in terms of how close can you get to the models. Where does the model break? So here it's an extreme close-up of a model, and see if you have the right data, can you get something that's really compelling? So here these are offline rendering. It's not yet real time, but definitely something that's interesting. Okay, so far we work on what are technology we can use to try to learn data and recreate you. And now let's switch gear a little bit and explore, okay, how do we customize? Because you might want to be like you might want to open up the space of creative inputs here. So one examples that I showed at the beginning is you can go for cosmetic changes, okay, and change hair or change clothes, which are, if your model is structured as the way we look at it, it's fairly straightforward to do because we have an understanding of physics. We know where things are. We know where the layers are, so we can easily synthesize something else and render something different. Same thing for the clothing. You might want to change your clothing, so it's important to understand fabric and simulations and be able to wrap new kind of materials and simulate them into different environments. So that's also things that we're doing. And as I showed before, we're looking into differential simulations in order to infer these properties, simulating different materials, simulating hair if you want to change your haircut. All of these elements have to kind of work together to do something that's compelling ultimately. So an interesting test that we did with our friends of the Codec Avatars team here, instead of changing the clothes, we're putting the clothes on. So this gentleman was captured without clothing, or minimal clothing, I would say, and we synthesize clothes. So the idea here is we drape the clothes, we simulate them, we render that, we put materials on them, and we light them with the same environments to showcase an interesting test here where we can put at this point any virtual clothes. So you can imagine, ultimately, you can take business meetings with your underwear and just have the systems dress you up, which is kind of nice. Just have to trust that the system doesn't break in the middle of the cold. But that's definitely something that's interesting. In terms of customization and motion, this is going to be very interesting. Also, it's like how can you control your motions or your expressions, and if you want at all to control them. One interesting aspect also that I mentioned is that if you don't have a lot of input for your motions, what can you do? So here it's research of using very limited input, and you're going to see the only input that this person is using here is a headset. So you have 6 degrees of freedom, and we try to train a system to infer the full body pose from this limited input. So you can see that the green dot is the only input, and the full body at the bottom is synthesized, and it starts to, it's not there yet. You can definitely see a lot of artifacts. There's something that's going to feel realistic to it, and it's not that far off from what the user is doing. So this is in a way to try to answer some of the questions that were posed earlier, like how much data do you need and what can you infer from very little input? And of course, sometimes it fails. Here's an example where there's more inputs. There's the headset and the 2 hands. And here you can do more complex poses. You can lean forward and start scribing on the board or these kind of things. And it's the same idea, it's the same kind of models. So here it's something that combines physics and dynamics, and having this basis is also something that would allow these characters to interact with the world and do things that are feel more physically grounded. It's important for the sense of immersion that the characters you render feels like they kind of obey some sort of physics. Now, moving forward, once you customize you do cosmetic changes, you can do motion changes, but you can also start exploring completely different characters, of course. Now, one of the benefits of our approach, as I say, is because we have all these structured informations and all these semantics, we can change just basically the outer layers of your models and be a giant ape or whatever of the sort of characters. Intrinsically, it's not that different. The idea here is to provide intuitive tools for people to design these characters, because it takes a lot of work to do that, and also to provide the tools for people to preserve whatever information they drive and they want to retarget on these. Do you want the characters to move exactly like you, or do you want this to be stylized in different ways? These are all very interesting questions. And the problem of driving characters that are different is also something it's not clear. So one thing we're doing is we're doing user studies and putting people in characters that are shorter or taller, and see, beyond the questions of how you're going to do it, it's interesting to know how are people going to react to it. Like, how do you feel if you drive a character that's much taller or much shorter than you? There's a lot of questions to that. You need to adapt yourself, because the characters and you will do things that are slightly different based on the change of proportions. You cannot have 2 characters with different topology do the exact same things. So the psychological aspect is also very interesting and something that we're looking into. So putting all this together, this is an old test that we did a while ago, where the idea is like, okay, how far can we push the physicality of that? So you had 2 people driving a clone that kind of looks like them. Here the focus was not on appearance, but more on the physicality, and we put a virtual bolt. So hopefully, in this case, they're in the same room, but they can be in separate environments. Everything is streamed over the network, and we can see, can you have a good sense of immersions, a good latency, and a good sense of physicality and all that. So this is a kind of things that we're looking at. So the idea here is that was just to showcase a broad spectrum of characters and design and experiences that we're exploring. There's more questions than answers, as I said, but really we want to find solutions that are very broad in terms of what it can enable and are kind of intuitive for people to create and reach the goal that they have, depending on their level of comfort there. So yeah, that's it for my time. I try to. Thank you.